Alright. Hello y'all. First video on this channel, and it's not gonna be amazing, but it's gonna be something. I was working on, you see it in front of you, I was learning pandas, the Python data science library. And while I was doing that, I used Jupyter Notebook for the first time. And I'd heard of Jupyter Notebook from other people, especially people who were just starting to learn Python or just starting to learn programming. Um, and I guess I kind of considered it kind of like a beginner's tool or something, or something new is really just mostly for the data science crowd. But as I used it, I kind of had this like realization that it was very much something I really liked the idea of, and was kind of I've been looking for it for a while. It incorporates some really cool programming concepts from a while ago, like together, um, in a way that I guess I have only I saw like one talk, like let me find it. There's like one talk, um, yeah, from this guy who talks about notebooks and dynamic programming. No offense, this guy. I mean, I'm sure his talk's like okay, but oh my god, it was long and rambly. I don't care that much. I mean, I care, but come on, man. Um, so this is also going to be long and rambly, just like not as long and rambly. So in literate programming, and so yeah, okay. Step back. So obviously we have like interactive like environments, right? Like, we can do whatever. We can say, like, sure, and then whatever. Yeah. We have in Lispland and probably other places we call these REPLs, read eval print loops, where it'll read your input, evaluate it, then print it. Versus if like here, like if I just put in 1 plus 1, um, like it will evaluate 1 plus 1, but it won't print it, right? It'll read it and it'll print it, and it won't loop, right? It's not interactive. But like in a Lisp or in a Python, you can do like this and it'll evaluate it and it'll print it, right? That makes sense. It's pretty cool. Um, and it's somewhat common for especially Lisp people, and maybe like this is like a closure thing. I don't know, on Hacker News and stuff, like they'll talk about this idea of repl-driven development, right? Which, as far as I understand, is just developing as in interactively. As you work, you can see output. It's basically you're trying to change any delay between input and feedback, right? You want to be getting feedback as you work as quickly as possible. This makes sense. Instant feedback's pretty cool. Everyone likes. It's a good time. Okay. But so there's a few problems, right? So first of all, like I'm gonna use Python as example. Lisps and like I'm sure all the Lisps have their own REPL environments. Like Emacs Slime exists for Common Lisp. There's one for Clojure. I don't remember. There's one for Racket. There's a bunch of environments that are supposed to help you do REPL-driven programming. I'm going to talk about Python because I think more people use Python. And even if you use a Lisp, it's way easier to think about Python as a Lisp user than it is to think about Lisp as a Python user. So we have Python, and we can do whatever. And I think the first problem like you run into if you're developing this way, right? And we can import like whatever turtle, and I don't know, turtle.forward 10, or whatever. There we go. Look at that guy, right? I think the first problem you run into here is you can't save, right? Like you can't save this interactive environment. So that's where like IPython or interactive Python would come in, and you can do same thing, or let's even do like that, and then you want to do import turtle, and like it has a little bit of completion. You have tab completion, and we can do like that, right? And there we go. There's the guy, right? There's the little guy. Sure. Turtle, could you close? Okay, whatever. So, but let's say then you want to save this, right? Well, what you would do is you can go save, and you can say, it's inclusive. So what lines would you like to save inclusive? I want to save lines 1 to 4, right? And I want to save, sorry, my bad, output file first. Then you say what lines you would like, 1 to 4, right? And that's fine, but let's say now I want to change x to equal 20, and this would be trivial if we were editing like a C program, right? Because you just go back and change that line, but here I have to redeclare it. And if I want to have this come in front of everything else, I have to save it as such. And what I mean by that is, for example, I want to have x equals 20 be first. So I do save line 6, then do lines 3 and 4, right? And overwrite that file. And you can see now it does in this order. But what if, like I have y equals x plus 1, and then z equals, v plus, or v, y plus 2. Like, as you have more variables that rely and intertwine on each other, having to figure out, like, okay, so I save line 6, and then, like, let's say I come here and, I do print out y, and then, like, actually, whatever, right? Like, now I have to come here and be like, all right, so I want to do, line x, and then 6, and then, like, 10, you gotta kind of think about what lines you're trying to actually save all the time. And as your program grows, you can see how refactoring in this way, although you wouldn't really be refactoring since you go back and refactor the file itself, but even small quick edits as you try to develop in this way are not really fantastic. And I'm going to pause here, and I'll say Notebook solves this issue, but I'm going to pause here to talk about literate programming, which I think is the far more interesting part of this whole ordeal, so I'm going to remove that file. So I think it's far more interesting to talk about literate programming. And it's by Donald Knuth, who is obviously the inventor of TeX. I have the source code to TeX here. We'll take a look in a second. Inventor to TeX. The author of The Art of Computer Programming. Incredibly, Donald Knuth, just look into him if you don't know him. He's done a ton of work, right? Possibly the most prominent computer scientist, academic computer scientist around, But he came up with this idea of literate programming. And I think Wikipedia does a good job explaining this, where they say literate programming is writing out the program logic in a human language with included, separated by primitive markup, code, snippets, and macros. Macros in a literate source file are simply title-like or explanatory phrases in a human language that describe human abstractions created while solving the programming problem, and hiding chunks of code or lower-level macros. These macros are similar to the algorithms and pseudocode typically used in teaching computer science. These arbitrary example phrases become precise new operators created on the fly by the programmer, forming a meta-language on top of the underlying programming language. Right? And that makes sense. And I agree with this. If you'd like to read it, you can read it later. The one thing I would like to note is literate programming is very often misunderstood to refer only to formatted documentation produced from a common file of both source code and comments, which is properly called documentation generation, or to voluminous commentary included with the code. This is the converse of literate programming. Well-documented code or documentation extracted from code follows the structure of the code, with documentation embedded in the code. While in literate programming, code is embedded in documentation, with the code following the structure of the documentation. There was also a critique by John Bentley, but Knuth came up with an 8-page long program, because I don't know if Knuth can think in concise ways, and all these books are really long too. But yeah, so it was published by a critique by Douglas McClory, which, by the way, this is the person who led the Unix, that part of Bell Labs, as Unix was happening, and has, contributed a ton to Unix as well. And so, regardless, he published a critique, but he noted that more practical, faster to implement, whatever, was only 6 lines of shell script. But the thing is that it doesn't really matter if it's 6 lines of shell script or 8 pages of whatever it was, Pascal. Web. I don't know. I'm assuming Pascal. It doesn't really matter because you can do both literally, as in a literate programming manner. And there's actually this where I should probably read this. McClure later admitted that his critique was unfair because he criticized Knuth's program on engineering grounds, while Knuth was only trying to demonstrate literate programming technique. And so there is this follow-up article, which I recommend reading all of, if you're interested. It's only 7 pages, but it's really interesting, where they did it in C. And you can see as they're talking about it, and they put everything in, and what, etc., etc. And you'll notice that as you read, it's kind of like, I remember, at least for me, when I was trying to read, I was like, so where is the code? Like, this is the article, but where's the code? And that's the point, right? Like, they're the same, right? These are tied together. I believe it might actually be called woven together. I don't know, something like that. Tangled. I don't know. Yeah, and this is just interesting in general because it's using this is pre-NCC, right? So like if it declares the names of the parameters and then you put the type information on the next line, it's a little weird, which is interesting by itself if you're interested in this sort of history. Otherwise, it's pretty much what we're used to. Alright, so I was learning pandas, and finally we can get to notebooks, right? And notebooks are kind of a culmination of multiple ideas where they enable this literate programming style because, I can write in the notebook as you write code, right? You have full markdown capabilities, including LaTeX capabilities, if I'm not wrong. Don't quote me on that if that's not true, but I'm like 90% sure. And also, when you print something, it prints very well formatted, and also, if you have a visual thing like a graph, that also gets printed in the notebook. So even without text, like I printed this frame just to help me think about what's happening and to debug, and I kept it because it almost self-documents the code. Anyone reading this later will also possibly find it conceptually useful to figure out what's in frame. And then, I wanted to get the group name, and it prints out what group names there are, and it, truncates and everything automatically, and then when I chart. So all of these are also debugging tools, including the text. So I think this is really useful, and I think this is really good in terms of, human-oriented design, right? Where as your program gets complicated, and especially if you have end users trying to use your program, or if you have someone new trying to read what your program does, this type of style is very verbose and very descriptive, and it helps people understand exactly what the code's doing. We can look at Tech, which was also written by Knuth, as an example of this. Also, this line's also a classic. Right, this is used to make section names sort themselves better. This is used for sort keys in the index via sort key. The main purpose of the following program is that, so these are and the thing is, the program and the documentation, you can't really separate them. You have these blocks of documentation, and they hint at it kind of being separate, but in reality, it's all documentation, and it's all code at the same time, and that's the point. Program tech. All file names are defined dynamically. Labels in the outer block. Procedure initialize. This procedure gets things started properly. Whatever, right? So this is really readable. If you're interested, I recommend taking a look. I'll put this domain into the description. And yeah, so the notebooks enable this style, right? And I have a few, and what's really cool about these is they're Python, right? And also they solved that problem, by the way. If you have like x equals a number and you want to change it to a new number, you can rerun the whole notebook, which very like fixes with that problem. Or if you want, you can just run one thing again. And like, I can do what we were doing earlier, where I import turtle, and then do this. Well, there you go. This is also not closing, so I'm just going to throw it away for a bit. But I was somewhat actually disappointed that didn't display in the notebook itself, but I'm assuming there is a way for it to do that. The only thing is that turtle uses tick-inter, so I'm not sure. But we can also, it's also language agnostic, so we can do like Racket. I have a Racket notebook here, and it's just require picture. You can draw whatever you'd like. Just one thing to note is like I can come here and like do this, but it's not really the best. This one might also be having issues because I restart my instance, so I'm not going to worry about this one too much. I just want to note that if you come in and edit later, it's possible if it requires certain libraries, you'll have to rerun the notebook for that to work. Something really cool that I think this could be used for is I'm always a big proponent of teaching not C++ necessarily, but language with manual memory management, especially if it's like C++ where you can interact with the pointers themselves directly. Like I don't care if the language has classes or not. I want to be able to teach memory, right? And I think this is a really cool way to do it. And I made this demo file, right? Introduction to pointers in C++, right? Like pointers are references to memory. And by the way, this uses this, which is a Jupyter kernel for the C++ programming language, which uses, do I have it? Yeah, Cling, which is the interactive C++ environment, right? This is really cool stuff. It's pretty crazy. Okay, I don't know how you exit this. There you go. It's pretty crazy, right? So if you're interested, I recommend looking into this. But yeah, so I can declare variables, print out their values, print out their like pointer values to demonstrate what a pointer is conceptually. Why like it's so much easier for me to say this is a pointer, this is what it prints out, that is a memory location, than for me to say pointers are like kind of like ints, but I don't know if I like it's it's like a very simplified model, right? Like I said here, to think of them as ints, especially because they're going to be, they're not going to be the same size as an int in many platforms, whatever, right? And you can still have comments, and you can still do regardless, like whatever you'd like, and you can do this interactively. And what's really cool about this is now, this is really useful if you want to do like a lecture, right? If you want to do a lecture, you can do this interactively live in front of the audience, and then you can publish this notebook, and your whoever you taught can go back and reference it later, right? Which is amazing. Like I wish I was taught like this. But yeah, and I also think it's useful for larger projects. I want to do a live project thing with this, but my live stream can't go up until like tomorrow because of YouTube reasons and this being a new channel. So that'll happen at some point. I'm still thinking of what exactly I'd like to write, but I would like to do a live coding thing with these for a new project, doing something, and we'll see how that goes. But as this encroaches on the 20-minute mark and the ramble continues, I think I'll cut it off here. I think this is really interesting stuff. If you're interested, check out the notebooks first. 30 minutes to an hour, you'll be going. It's really easy to pick up. Find a language, whatever language you like. Most of them should have kernels. I don't think C does is the one that I couldn't find. I know Scala does, maybe Java does. I'm not sure. Whatever. Find. You can probably find a language that you like with a kernel, and just go with it. It'll take you 30 minutes to an hour to get started tops, and I think it'll be a fun time for you. And I will say another project that uses this that I think is really cool is Chisel, who have their tutorials in these binder notebooks, right? And this is really cool. So yeah, so this is being used. I think this is a larger project that's using it, and I think this is a really good application of it. And I hope you look into it. If you're interested in the rest of it, I recommend coming here. This file is linked to, one moment, making sure I know where it is. It is linked to right here. So I'm going to link this in the description. I'm also going to link, I'm going to link this Wikipedia article. I'm going to also link this tech source code. And I hope you enjoy it, because I think this is really cool technology, and I think this is a new paradigm and an interesting way to work. Alright. And after 20 minutes, I will see you guys in the next video or live stream. Thank you for watching.